Okay, plant science students, we're gonna finish this lesson here today by talking about the 5 soil forming factors. So you'll be able to list the examples of them, and then also we're gonna look at you'll be able to describe the different soil horizons in a soil profile and know what each element there, or what particles are actually in the horizons there, what compose those. So let's start off today by talking about the 5 soil forming factors, and these are the 5 traditional factors here. We have the parent material, time, the climate, organisms, and topography. Maybe if I do this, I might be able to. There we go. And we're going to go through each of these and some of the different vocabulary that go with each of them, so you know what each of them are. One additional factor that they talk about is humans actually influencing different soils that form, and that is something that does happen. Think about different construction sites and other areas like that where you're moving soil around. That definitely is a factor that could lead to new soils forming. But these 5 here are the common ones, how soils actually form. So the first one we're going to talk about is parent material. This is rock or other material in which soil is formed. Limestone around here is definitely one of the most common. That's kind of the bedrock at the very bottom of a soil, and over time, through weathering and other processes, that limestone is turned into soil particles. The chapter talks about lowest soil, which is wind-deposited silt that is blown in. But this is kind of a silty soil, and it is a nutrition-rich soil. One of the things under parent material, so there is a couple different factors that went into making this parent material, where it comes from. And one of them is glaciers. Thousands of years ago, glaciers did cover parts of the United States. And so there's all these glaciers actually left a lot of debris, which is in a general term called glacial drift. Glacial till then is as the glacier started to move, they started to also tear away through abrasion, or through pretty much tearing away at the land. And so these accumulations of all of this, the clay, silt, sand, gravel, boulders, all that stuff, as the glacier started to melt, also accumulated and then created this glacial till. Glacial outwash is just simply saying wherever the glacier was, as it kind of started to melt, streams started to go through that, and those streams then carried different debris and deposits away from the soil, or from the glacier as well. And lacustrine soils, or lacustrine is just simply saying deposits at the bottom of the glacial lakes that came from this glacial outwash. So these rivers flowed, and that's where the deposits are. So that's glaciers. And here's just a picture of kind of what it is. Here is a glacier here, and as it moves, it's going to this till is as it melts here. Okay, another way that parent materials were created, or soil deposits were created, through wind. And wind deposits are called aeolian soils, and this is when the parent material was carried in by the wind, and Nebraska's sandhills would be an example. A lot of the sandy soils are examples of that. And then water also created this parent material. We have alluvial soils, and then with alluvial soils are alluvial fans. So as water causes erosion or other things as it moves, it's going to carry soil deposits with it, and that would be alluvial soils. And then alluvial fan is pretty much, it says, at the base of a mountain or a stream somewhere, where the streams kind of fan off or go in a lot of different directions. And those alluvial fans are going to carry these alluvial soils. So here's an example of the aeolian deposit. You can see the sandy soils are being blown away, and they're going to be making these sand dunes. Another one is alluvial soil. So as this stream goes, it's going to carry lots of deposits with it and going to create new soils in other places. 3 other ones that affect parent material are gravity, which is colluvium. This is just simply parent material or the deposit sliding down or rolling down a hill or slope. And talus is the sand and rocks that collect at the foot of a slope. Volcanic deposits, of course, we know volcanoes are very relevant in making new soils in parts of our earth. So that's another one. And then organic deposits. Simply mineral soils versus organic soils. Next chapter, we'll get into this more. Mineral soils contain less than 20% organic matter, and organic soils contain more than. Organic soils are organics matter is just simply that decaying dead material from plants or from animals that has decomposed over time, and that does create a nutrient-rich soil. So there's colluvium, simply just the deposits there through gravity. And then another one here. Okay, so parent material is one soil forming factor. Another one is time. So over time, there's definitely, time does play a factor in a lot of different things, because plants die, animals die, they get into the soil, decompose into the soil. And so nitrogen is lost, nitrogen's gained through lots and lots of time. So there's young soils compared to mature soils. And then old soils can be leached over time. Leaching is just simply as nutrients flow through the soil, they can be lost. So here's an example of an old soil versus new soil. Or actually, I should say a new soil versus old soil. Old soils, you can prominently see some of the soil horizons. We'll talk about in just a second. But there's more soil horizons in an older soil than a newer soil. So you can see all of these areas, these soil horizons are not very well defined yet, and that means that it's probably a newer soil still working on time. Another soil forming factor is climate. So we got parent material, time, climate. And through the process of physical chemical weathering a rock, that's how climate definitely controls soils. How much rain you get, snowfall, all of that is going to affect how soils are formed. And so there's just another picture of the weathering process. Okay, and then our fourth one here is organisms. Okay, at the beginning of the chapter, we talked about how all these organisms really go into the soil. Soil is not just dirt. Soil is everything that is composed with it. The decaying matter in it, the microbes, the insects, the animals in there. Soil environments compose all of that. And so grassland says has the highest organic matter because those grasslands, mollisol soils are the order. Those definitely have high organic matter. And those are nutrient-rich soils. Forest soils don't have as much because it's just trees and a lot of plants can't grow underneath. They need more sunlight. But organisms definitely play a huge role in forming soil. And our last one here, there's just a picture of all the different microbes that go into a soil environment. Our last one is topography. Topography is just simply the soil's position in landscape, how it can influence it, okay? So simply like in a river. The river is a natural part of the landscape of the soil or landscape of the land, and that's the topography. The mountains are part of it, the sand hills, all of that goes into it. And so through that whole process, soil is going to be forming, and some soils are going to form differently. And then we talked about humans can definitely have an impact on that. So our top five are parent material, climate, or time, climate, organisms, and then topography. There's another picture of that. Okay, our last thing I want to talk about was the soil horizons and profile. Soil horizons can be created through different losses of soils or translocation of soils, meaning that particles move from one area to another. So we're going to be looking at a soil profile, which is just simply a vertical section through the soil, and we can see all the parent material and everything in there. So here's our soil horizon. There's topsoil, which is mainly here. That's the A horizon. The B horizon is subsoil, and C horizon is parent material. And then the O horizon is the organic layer. This is the decomposed, undecomposed organic material. This is what creates a lot of nutrients up here. Then as over time, it goes down into the A horizon, and a lot of times you see A horizons that look like this here. That is a very nutrient-rich A horizon, and you can really see the soil horizons here. So then the A horizon is a lot more organic matter here, high in organic matter. Some, rock material, but a lot of organic matter. This E horizon sometimes happens, a lot of times happens in older soils. It's this area that is, a lot of this is lost by leaching. The B horizon is a lot more clay material. Getting into the C horizon is a lot more clay or unconsolidated. We're getting into more rocky soil here. And then the R is the bedrock. This is like that limestone or whatever is at the very bottom. And around here, that R horizon and C horizon is composed of a lot of limestone. So you can see here, the O horizon is here, organic matter. Then the A horizon is this darker, nutrient-rich area. Not really much of an E horizon here, but you can definitely tell this is B. And then C getting down here, clay material here, and then our bedrock down here. It's a very good picture of an O, A, B, C, and R horizon. So that concludes this presentation here. And this is just kind of the summary questions. You can look at yourself, or not look at yourself, but think to yourself, what are some of the answers to this, and it'll help you on your test review. So if you have any questions, please feel free to contact me. And thank you for viewing.